Hey guys, so I just learned today that there's another way to graph your trig functions pretty quickly. So I really liked it. One of your classmates was in the Cal Central, and I saw on the board, and they were doing this problem here, and I thought, wow, that's really interesting to see it that way. So I want to share that with you. This is something that I learned today too. So what you're gonna do is that write down the function that you need to graph, and then always refer back to the parent function, right? Since this is sine, we're gonna take a look at the parent function of sine of x. We know that the period is 2 pi, right? Just a refresher, sine, cosine, the periods are 2 pi, and tangent would be pi. Okay, so the graph of sine, I will start with 0. Sine of 0 radians is 0, right? So we start here, okay? Since the period is 2 pi, you know that the distance between the one peak to the other is going to be 2 pi. So 2 pi here. And one cycle looks like this, right? Okay, and we know halfway between 0 and 2 pi, that's 2 pi plus 0 is 2 pi, divided by 2 is pi. And then the middle of this here, basically again, midpoint, right? Pi plus 0 divided by 2 is pi over 2. And then the middle of 2 pi and pi, you just add them, then divided by 2 again. And that's 3 pi over 2. So that's the parent function. So that's the idea there, right? Dr. C also talked to you guys how, so again, the period is 2 pi, right? And if you want to know what values those four things are, you just divide it by 4. So that's pi over 2. Do y'all see how from 0 to pi over 2, that's pi over 2. Pi over 2 to pi, that's pi over 2. Pi over 2 to 3 pi over 2 is pi over 2. So it goes on by pi over 2. So keep that in mind. Okay. All right. So let's move on to this here. Y equals to 4 sine of pi x plus 2 minus 5. So what I would do is start with this. So do y'all notice that in the parent function, this is, excuse me, f of x of sine of x is the same thing as f of x equals sine of x plus 0, right? That 0, or that y-intercept, this line here is your midline. Do you see how in that midline we have 3 intersections there? So if we move 5 units down, what do you think would happen? If you guessed that the midline would also shift 5 units down, you're correct. So 1, 2, 3, 4, 5. Okay. So you should expect these 3 intersections to be on that yellow line there. Okay. All right. Okay. So again, one cycle here on the parent function is 0, between 0 and 2 pi, right? But now, in this new function that we have here, I'm going to keep the original parent function 0 to 2 pi, but now in the middle we have pi x plus 2. Do y'all see the difference? This is x here, right? But now we have pi x plus 2 here. So my goal here is to make only x left in the middle. So what do we need to do? So naturally, I want to get rid of the outside first, which is subtracting by 2 here. So what you have left is negative 2 pi x less than or equal to 2 pi minus 2. And then I want to get rid of that pi in the middle. So divide by pi on all of these. Okay, negative 2 over pi. So you only have x in the middle now. Okay, and I'm going to leave it in this form here. It does kind of look ugly, but trust me, it's going to help us out in here. Okay, so you're actually, you already have 2 points here. This is what I'm talking about. So do y'all see how 0 and 2 pi, these are my endpoints of that cycle, right? So that means negative 2 over pi and 2 pi minus 2 over pi, those are my 2 endpoints in my cycle as well. So I'm going to approximate where negative 2 over pi is. It's going to be a small number, so this is not to scale here. Negative 2 over pi. And remember, the endpoint is on that yellow midline, right? So I can expect that negative 2 over pi, even without doing math here, even without working it out and putting it back to this function here, I can expect it on that yellow line, okay? So that means this here, 2 pi minus 2 over pi, that's the other end of the line. Again, it's not to scale, I'm just sketching it out here. Okay, so I expect it over there. All right, so remember, there is another point on that yellow line, which is the point that's halfway between these endpoints, right? So that means I need to find what's halfway here so that I can put a point here. What did we do first in that first function? We added 2 pi plus 0, and then I divided by 2. That's how you find your midpoint, right? So 2 pi over 2, that's pi. That's how I got this point there. So I'm going to do the same thing on this function here. So I got 2 pi minus 2 over pi plus negative 2 over pi. And I'm going to divide that by 2. Okay, so 2 pi minus 2 plus negative 2, that's 2 pi minus 4 over pi and divided by 2, right? That's the same thing as multiplying by half. So I get 2 pi minus 4 over 2 pi. I'm going to simplify that. That's going to be 1 because 2 pi divided by 2 pi is 1. Minus 4 over 2 pi. That's 1 minus 2 over pi. So your midpoint here should be 1 minus 2 over pi. So that's your other point. So you're almost there. Okay? Again, do y'all notice that I don't even have to plug it back into this equation, right? So I need to know these 3 points. Okay. So remember how I obtain these points, the max and the min? Because again, this value here, that is halfway between the start of the cycle and the middle of the cycle, right? So I'm gonna have to do that for this and this. So again, to find the midpoint, you need to add these two numbers together. Divide by 2, okay? So that's 1 minus 4 over pi over 2, or 1 minus 4 over pi times 1/2. Distribute that, that's half minus 4 over 2 pi, or 1/2 minus 2 over pi. So do y'all notice that that's, it's less here, right? And this is 0.5. And that number is 2 over 3.1415 blah blah blah, right? So I expect that it's gonna be a negative number here. Wait, hold on a minute. 1 minus 2 pi plus negative 2 pi. That's minus 4 over pi. Maybe I should rewrite it this way. So it's pi over 4 over pi. Do y'all see what I'm doing? Pi over pi is 1 over 2 pi. How I got that is that pi over 4 times half. Pi over 4 over 2 pi. So I know that this value is going to be negative. So that's the reason why I wrote it this way. So that I can approximate. I don't even have to know the exact value of that. Pi over 2 pi. So it's somewhere here, right? So I'm going to leave that there. And it's going to be the midpoint between this and this. So if that's my x value, what would be my y value? And notice that, again, going back to your parent function, this was 1 and that's 1, right? Your parent function, remember that the amplitude here is 1, right? So I expect that the distance between the max and the yellow line here should be 4. Okay, so 4 up would be 1. So let me write this. 4 units up is 1, 2, 3, 4. So my point should be here. Okay, so that point is pi minus 4 over 2 pi, comma, negative 1. That's your max. And you should expect that your minimum, 1, 2, 3, 4, should be somewhere down here, right? Because this is 1, 2, 3, 4 units down. That's your amplitude. So this is your expectation here. So what's left to do? You only need to find this value here, midpoint between this number and this number, right? And do the same process. Add them together. I'm going to rewrite 1 minus 2 over pi as this. Okay. And then you have to divide it by 2. So that's 2 pi plus pi, that's 3 pi. Negative 2 plus negative 2, that's negative 4. Over pi times half. That's 3 pi over 4 over 2 pi. Okay, so you're done. These are your values here. So this would be 3 pi minus 4 over 2 pi, comma, negative 9. And these are just, they all have the same y values. And that's all. I hope that helps. If you think this is more difficult, then don't do it. This is just another way to graph your trig functions. Okay. All right. Have a good one.